This patch of grass behind me looks pretty ordinary, doesn't it? Just some trees, a bench, and maybe the occasional lost magpie. But once upon a time, before it got turned into a nice spot for picnics, it was home to Australia's very first radio telescope. You wouldn't know that unless you read the sign on the other side of the park. And if you didn't read it, well, you'd still be standing in a park completely unaware. The telescope itself is gone now, probably off doing telescope retirement things, but its legacy still lingers. Thanks to this, Australia became a world leader in radio astronomy, discovering weird things in space, inventing Wi-Fi so you can watch those cat videos in bed, and even helping broadcast the first moon landing. But how did that all happen? Well, we'll get to that soon, but first, what even is radio astronomy? It sounds like someone stuck a radio on a telescope and basically called it a day, but it's actually much more scientific than that. Luckily, astronomers like to name things in the most straightforward way possible. Black holes? Yep, they're black and hole-like, except not really at all. That was a bad example. How about the Big Bang? Well, it was big, and I think you get my point. So radio astronomy is exactly what it sounds like, studying the universe using radio waves. Now, unlike optical telescopes, which pick up the tiny sliver of light our eyes can see, radio telescopes work at much lower frequencies. Instead of looking at space, they're more like cosmic eavesdroppers, tuning into the universe like a big ear. In fact, one telescope was literally known as the Big Ear. Except instead of your favorite music station, they're picking up on signals from exploding stars, distant galaxies, and sometimes mysterious things we don't fully understand yet. So basically, the universe is constantly sending us radio signals. We just need the right equipment and tools to listen in. And that's where radio astronomy comes in. So how did Australia go from having no radio telescopes to leading the field? Well, it started with some clever scientists, a bit of wartime innovation, and a whole lot of leftover radar equipment. Let's talk about it. After World War II, Australia had a surplus of radar technology, and a team of researchers at the CSIR Radio Physics Laboratory in Sydney, which yes, later became CSIRO, they decided to explore peaceful uses of radio, such as studying signals from space. But rather than starting from scratch, scientists at CSIR saw an opportunity. The radar equipment once stationed here at Collaroy Plateau. Now, it was originally used to detect incoming aircraft over Sydney during the war, but they realised that it could be repurposed to tune into radio waves from space. And that led to a breakthrough on October 3rd in 1945. Using the repurposed radar equipment situated here at Collaroy Plateau, Dr. Joseph Pawsey, Ruby Payne-Scott, and Lindsay McCready made Australia's first successful detection of radio waves from the sun. Between October 1945 and March 1946, when possible, the team observed the sun at sunrise and sunset every day. From their observations, they discovered that the radio signals to the sun change over time, with significant variations from day to day. And they found that these fluctuations were strongly correlated with sunspots. They also detected a base level of heat energy from the sun to be around 100 times higher than expected, with temperatures up to 10 million Kelvin. And this was a big surprise to them because the visible surface of the sun has a temperature of around 6,000 Kelvin. What this discovery revealed was that the sun's outer atmosphere, called its corona, is way hotter than its surface. Now, this is something that scientists had thought might be true since 1937, but this was the proof they needed. And the reason why the sun's outer atmosphere is so hot is still a mystery to this day. From the humble beginnings at Collaroy Plateau, a new way of seeing the universe was born. What started as an experiment with repurposed radar equipment quickly evolved into world-leading radio astronomy research, laying the foundation for future discoveries and the development of major facilities in Australia like Musictown, the park's radio telescope. With momentum building, Australia's next major step in radio astronomy came at Dover Heights in Sydney, where another radar system was adapted for scientific use. Here, astronomers made a discovery that shocked the astronomical community. They detected two powerful radio sources that turned out to be entire galaxies millions of light years away. At the time, scientists believed all radio sources were stars. So the revelation that radio waves could have come from entire galaxies put Australian radio astronomy on the world map. Dover Heights also played a key role in other major breakthroughs. Astronomers detected radio waves from the Crab Nebula's pulsar, although they wouldn't have known it was from a pulsar at the time because pulsars were discovered by Jocelyn Bell Burnell in 1967, 13 years after the Dover Heights radio facility was closed down. Pulsars are rapidly spinning remnants left behind after a supernova explosion. They emit precise, repeating flashes of radio waves. And since then, Muriang, Australia's Parkes radio telescope, has detected over half of more than 2,000 known pulsars. Another milestone at Dover Heights came when Joseph Pawsey's team built a dish-type telescope and used it to pinpoint the center of our galaxy, which was a crucial step in mapping the structure of the Milky Way. Then came 1961, and with it the opening of the 64-metre Parkes radio telescope in New South Wales. No, I am not at the dish. I am back at Collaroy because I didn't have time to drive all the way to Parkes for this video, so this will have to do. Today, the Parkes radio telescope is known as Muriang, and it remains one of the world's most productive radio telescopes. In terms of scientific impact, it's the second most highly cited radio telescope in the world. But for many, Parkes is most famous for one thing: helping the world witness the first moon landing in 1969 by receiving and transmitting television signals from Apollo 11's historic broadcast. And while not a direct astronomical discovery, radio astronomy in Australia led to one of the most important technological breakthroughs of the modern era: Wi-Fi. So from unveiling hidden galaxies to revolutionizing everyday technology, Australia's legacy in radio astronomy is a testament to scientific curiosity, ingenuity, and a few lucky leftovers from World War II. And the discoveries aren't stopping anytime soon. Thanks for joining me on this journey today, and fun fact, today is actually World Radio Day, which is the whole reason why I decided to make this video, because my thought process was like, okay, World Radio Day, how do I connect that to radio astronomy? Radio astronomy? Duh. How do I try to reach more Aussies? The history of radio astronomy in Australia. Perfect. Double fun fact, I also grew up here in the Northern Beaches, but I never quite knew this little tidbit about the birth of radio astronomy in Australia, so that's pretty cool. What did you enjoy about today's video most? Drop your answers in the comments, and until next time, stay curious and keep looking up. Bloody hell, it's hot. Why did it have to be so warm?